Okay, we got enough? Okay. So flipping a coin, as Allie and Elena and Chance and whoever else said, is a fair proposition, 50-50. What if you spun it and let it fall? So, like this.
It'd be weird.
Well, it'd be weird. Well, let's do it. Let everybody try to spin it.
Yeah. I'm not quite sure.
That's what we're gonna practice. Practice right now until you can actually spin the pennies. Okay, and then let them fall. Let them fall. So spin it, get it spinning, and then just let it fall down. Is that fair? Okay, do it a couple times. Make sure you can do it consistently. I've seen some students do it where they flick. They hold it with one finger and then flip the edge. Whatever I do, that turns into a projectile, so I'm not going to do that. You do that. You do that, Chance. That's good. You can do it. That's awesome. I do it two hands like this, and then I pull them opposing.
That's even way harder.
Your way seems impossible. So I personally do it this way to see if it feels safer. I don't risk putting anybody's eye out doing it that way. Now there's a couple things I want to make sure that you do. Make sure that when you do it, it doesn't bump anything. Like a lot of these desks have these gaps between the side desks. If it ends up, Katie, I'll work with you. I got you. If it hits the gap, we're not going to count that as a trial. I want it to get spinning, and you can tell when it starts spinning. It starts almost like humming, and then let it fall down. And that's gonna be our trial. So make sure you can do that. Make sure you can do that. Katie, I'm gonna come work with you. That one's good. That's legit. Once it doesn't go too far that way. Oh, Katie figured it out. You got it, dude. Katie's got like a one hand, like boom, like a twist thing going on. That's good. Chance, what you got? You think you rigged it? You come up here. Now, everybody, what I want you to do first is, I want you to ponder this. What's the chance it lands heads up? 50-50 still? Okay, good. Whatever your guess is, put it in number one. What is the chance the penny lands at? It does not have to be 50-50. Here, show me, Chance. Oh, you got yours. That's yours. Go ahead. Wherever you want. Floor, desk, over here maybe. But it's good.
What do you want to roll?
What I want you to roll? Heads. No idea. Oh, I love this. I wish I had known you were going to do this. We could have made this the warm-up. Did you rig it the opposite way? Does it go on tails?
I could.
Now, Chance, without getting too far into it, you got 3 times in a row. You know what the chance? So Chance, everybody.
I love this.
This class makes me so damn happy. You know why? Because they say shit like this. Do you think getting it right 3 times in a row would be statistical evidence that you have rigged? Because what Chance said is, I think I didn't call it. Tails. Oh shit, I have to tell you ahead of time. I gotta tell you ahead of time. I can't tell you. I can't tell you. Yeah, you were going for heads. Oh, you were not.
I actually was.
You were. So that's 4 times out of 5. It's 4 times out of 5 evidence that he's rigged it. And the answer is no. We're going to analyze it later. Using a tool we're going to learn today. Strategy. Okay, does everybody have a guess for the probability of getting heads? I heard a couple say 50-50. That's totally fine. 50% is fine. No answer is wrong here. I'm asking you to guess. But I do kind of want to know what you put. So some of you said 50-50 because I'm assuming that it's the same as a coin flip. Like whether you spin it or flip it, it's spinning. So there's no difference. Did anybody put something different besides 50-50? Or did most of you put 50-50?
Isn't like one of them slightly heavier?
Well, I don't know. I mean, I want you to get, you're either going to get heads or tails. Has anybody gotten it to spin so that it hasn't fallen down? Students are always concerned about that. Like if they spin it, it'll just spin and then stay up. I've never seen it happen. I guess it could happen, but I've never seen it. No, okay. So 50-50 pretty much across the board? Okay, that's good. That's good. Now, here's the deal. When we do statistics, which is what we're getting into today, there's very often a percentage of something out there in the world that we want to analyze. For example, what is the chance when I walk out to the car to drive to Madras after this class today, I'm going to have a flat tire on that car? I'm going to answer 50-50. Because I either do or I don't. Now, what is wrong with that logic? What does 50-50 actually imply? It implies two things. Ray, talk to me. Or tell me what you're going to tell me. Tell me what you're going to tell me.
You're neglecting like other outside factors.
Oh, that's very true. So Ray's already upset that I said 50-50 because 50-50 means equal chance. It means there's two things that can happen, and there's an equal chance of both. Now, there are two things that can happen on that car. I might get a flat or I might not. That's two things. But hopefully you appreciate it's not 50-50. I mean, you're not getting flats half the time. If you're getting flats half the time, something's wrong with your tires or where you're driving, right? So lots of things in life have two outcomes, but they're not 50-50. Coins, however, we've been predisposed to think of them as 50-50 random number generators. But we always flip them, right? We always do this to decide. I'm going to mess with that a little bit today and see if we see any difference. So everybody, spin your coin 10 times. And then write down out of those 10 the percentage of the time you get heads. If you haven't already, it sounds like you've already done it, Jeff, and that's totally fine. I'm going to do it too, because I haven't done it myself. So 10 spins, and then write down what you get in number. Put your glasses on your head, Sean, so you don't lose them. There we go. And then we'll regroup in number 3 after you answer number 3, which is the why or why not. One go and speed things up. I'm not supposed to speed things up. In that movie. I'm not supposed to speed things up. Look, this is not as easy as it is. If you're in such a hurry, you could lower a rope or a branch or something. Well, I do have a rope up here. But since I'm only waiting around to kill you, I do not suppose you'll expect my help. Come on, what movie is this? There we go. Thank you, people. Jesus. I'll do the whole script if you need to. How's the sick? Are there any Spinal Tap fans in the house besides, Rob Reiner, movie fans? Okay, never mind. I'm not going to share that trivia with you. You're not going to care, or it won't make any sense to you anyway. I'm spinning. Oh, don't touch that one. Remember, if it hits anything funny, don't count it. Like if it hits the gap in the table, don't count it. Eight, 9, 10. All right, see what we got. What do I got? 1, 2, I got 50-50. This is mine. Oh yeah, it's yours. I got 5 and 5. Anybody get 5 and 5? Anybody get, who got more heads than tails? Okay, more heads than tails. Okay, cool. Who got more tails than heads? Okay, cool. And then who got equal? 5 and 5? That was me and Amelia. Just me and Amelia. Okay, that's cool. That's cool. So, we all got something different. Does that surprise anybody?
No.
Hopefully not. So, I think I know how you're probably going to answer number 3. Do you feel confident? I'm going to let you decide what confident feels like. Saying that whatever you got in number 2 is the actual true percentage. Because when we talk about flipping coins, we say 50-50. Nobody ever thinks a second. It never gets a second guess that. It's 50-50. Equal chances. So, for example, I just got 50-50. And so did Amelia. But some of you got 40%, 30%. Some of you got 60% or 70%. Would you feel confident saying that was the actual true percentage of spinning coins and getting heads? And why or why not? So give me your answers. I see most of you are shaking your heads, which I love. You're shaking your heads no. Of course I wouldn't do that. But verbalize why you wouldn't. Why wouldn't you do that?
Well, I just said, because I didn't take anyone else's risk.
I like Allie's like, that would be a very selfish thing of me to do. Would it not be very selfish for me to do that? I mean, who's to say that my 10 trials are representative of all the pennies? I love that, Jasmine. Go.
Also, every time we be spinning at different speeds. We be spinning at different time.
Love that, girl. So I tried to control for that a little bit because when I was watching you spin, and every time you spun a penny, the idea was get it so that it very often they wobbled, like kind of that's wobbling. But the idea is you get it spinning so that it gets to that point. Once it gets to that point, physics has kicked in. There's no weirdness, you can't control it anymore. That's a good. Your concern is an experimental one, where Allie's concern is a sampling one. I love that you have two different concerns. Very, very good, both of you. I love that. Anybody else? Did anybody say yes, mine's right, and the rest of you are wrong? Probably not. Thank you for laughing. It was a terrible joke, but thank you for laughing, Mariah. I appreciate it. Okay, now, let's go to the side board over here, and let's put our data together. Let's put it all together, shall we? Yeah. So, number of heads. I'm just going to try to go around the room over there. I'm just going to ask you. You can give me your percentage, or you can give me how many heads you got. It doesn't matter to me. I can turn your percentage into a number of heads by taking this. Actually, just look at your percentage and take the 0 off. Boom. That's the number of heads, isn't it? I'm overthinking this. So I got 5. Allie, you got 3. Actually, this is dumb. This is dumb. 8.
6.
14. How many heads, Kristen? 7. So that's 21. 24. 28.
3.
31. 36. 43.
None.
52. I think you had 9. You got 9?
None.
Oh, none! Shit. I said 52, right? And I thought you said 9, so that's back to 43. Woo, you got all tails? Holy shit. That's cool. 43. Reminds me of Abby from last term with that damn flipping the coin thing. It's ridiculous. What did I say? 43? I'm done being impressed now. 43? 46? 51? 52. Whoa! 52. 59. 61. 63. 69. We have 69 heads, and that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 170 spins. Okay, my dear friends. Number 4. What percent did we get as a class? What percent did we get as a class? While you're doing that, I'm going to input our data into my master list. Master! Another great friggin' album. We get 170, and we've got 69. Bold. Okay, here we go. Coin spins historical. 170. Alright. Bold. Oh, no, that was already bolded. Alright. Okay, my dear friends, what percent heads did we get? 41? That divided by that, 41%. Number 5, would we feel confident saying that that is the true percentage of, Elena's already shaking her head. Woman? Why are you shaking your head? We got more, we got 170 trials. That's 17 times more. Still not, what's enough? Oh, I love that. It's not enough. It's not enough. We need more experimentation. I agree. First of all, I agree. As long as we're doing good experiments, more is always better than less.
Also, the 10 tails probably threw things off.
Ah, okay. Obviously it happened. And did you catch the 9 tails and the 1 head back there? We got 1 head, 9 tails, and also 0 heads, 10 tails. So that's going to pull that average down a little bit anymore. Over 170. So thankfully, I predicted that some of you would actually say that no, we didn't have enough trials.
Yeah.
How many of you were born after 2006? Okay, a couple of you. I've been doing this experiment longer than you've been alive. Because I'm a freak, of course. I don't know when this came to me to start doing this. to start looking at penny spins versus penny flips. It was a long time ago. It was 20 plus years ago now. But I've been collecting the data ever since 2006. So here's a look at some of the data I've collected. There's y'all, right there. Here's spring 24, last time I did it. Very small class, only had 40 spins, of which 16 were heads. 240 spins back in fall of 23, 111 were heads. 330, 162, 330, 142. Goes all the way back to early, whatever the hell early is. It's before fall 2006. I have no idea where early came from. The spreadsheet's been around for over 2 decades now. What do you think? What do you think? Anything jump out at you there?
Seems like they're all close to 40%.
Yeah.
Ooh! Oh, so this might be a little hard to see. So what I decided to do, and I go ahead and I just did this for you. A little hard. Let me zoom in a little bit here. Okay, so here are the exact same data with the percentage. It's called p-hat there. Don't worry about that. That's just a percentage, probability. It's a statistical term. It means the sample percentage, p-hat. You'll learn it in 243. You can ignore it right now. Probability, call it that. So in early, we got 43% hits. Fall 06, 39. Winter 07, 42. Spring 07, 43. 45, 43, 43, 30, 39, 40, 42, 43. What the hell's going on? What looks like is going on? What does it look like is going on? It's a hard sentence to say. Okay, problem one. What does it look like is happening? God, what appears to be happening? There we go. I knew it. I knew if I kept saying it, it would eventually come out sounding grammatically kind of correct. What appears to be true?
Closer.
It appears that tails is a little more likely than heads. Now, here's a little graph. Does this graph, and I love this graph because of that damn spike right there. Does this graph, let's see if I can get the whole damn thing to fit, hang on. Make it a little bit bigger so it zooms in and fills the screen better. Uh-oh. Move that, move the whole thing. I heard a knowing from somewhere. Tell me what that was all about. This is out of the way. These are the percentages of heads down here at the bottom. Does it appear, based on this graph, that tails are more likely than heads? This is graphing the percentage of heads. And if you can't see it, I started down here at 30%, then 31%, 32%, 33%. This is counting all these times, what percentage we got heads in each of the trials. So these are different numbers of spins each time, but it's percentages each time. Is that fair? So there was one class that got 51% heads. I forget when that was. You can go find it if you want to. One class got exactly 50% heads. One class got 49% heads. It's like 2 classes got 48. 4 classes got 47. Where are y'all? Oh, you're 41, right? Is that correct? 41%? So y'all made that 5 go to 5 from 4. Oh, I like to watch that happen. Hang on. Let's put your data back in and then watch it change. And here you go. Boop. There you are. It's fun to watch real-time data collection. And this is one of those things I can't simulate. I can't like make an Excel spreadsheet to spin a penny. You know why? I make a lot of Excel spreadsheets to simulate stuff, right? I simulate rolling dice, I simulate flipping coins. I never made an R2-D2 on a 98, did I? You know why? How come? Why can't I make one for this?
Too hard to predict.
I don't actually know what the true percentage is. Even now, 20 plus years later of doing this experiment, I still don't know what the true percentage is. I've got a pretty good feeling of what it is. I've got a pretty good feeling of what it is. As a matter of fact, I got an idea. You ready? Oh, I got an idea. You ready for this? I have spun with my students 13,000 308 times. How many heads have we all gotten? 5,826 heads. Therefore, the percentage we have gotten of heads is 43.78%. Should I say that's the exact probability? Should I say that's the exact probability? Ashton, why? 13,000. Elena, do I have enough trials yet for you? This is all because of Elena. Just I'm going to blame Elena. No, I'm kidding. How come, Ashton?
Because we're still gonna need more trials.
Because if I did it again, let's just see what happens. Let's just see what happens if I took out y'all. Okay? Look, it just changed a little bit. It went from 43.78 to 43.82. Probably because of those weird little outlier results that we saw with no heads and 1 head out of 10. So in other words, as much as I want to believe that is the true percentage of Amelia's already shaking her head. No, you can't. Do you believe it more than you believed your answer in number 2?
Well, yes.
Well, yes. Do you believe it more than you believe your answer in number 4?
Yes.
So the question I have is, when can we believe it for real? Like, when can we stop going, I believe it more, but still not 100% correctly?
After everybody in the world does it.
Great. Thank you, Ashton, for proving the point.
Oh, no.
No. Your answer, that's 100% correct. The only way we could be 100% certain in the answer that we're going to get correct is if every single person in the world spun pennies from now until the end of the universe.
Oh, jeez.
But then if you think about it, we still wouldn't be done. Because some alien out there would be like, you didn't finish. And your son exploded, so now you can't. Nicole, I tried to warn you. You have till the end of week 2 to get your money back. No. You're going to take 105 with Sean. Okay, so I'm handing you a set of notes, which are the slides from a PowerPoint that we're going to work through today. And Ashton, thank you, my dear friend, for already starting us down that path. I treasure you all. All right. And we're going to hopefully address Ashton's solution. Unfortunately, the solution is not going to work in general because it's impossible to do, but we're hopefully also going to nod to Elena's concern. Y'all feel better about the 43.78% than you did about our 41%, and much better than you did about our quick little sample of 10. Hopefully. Good. But the thing is that none of them are certain. You're never going to know. This is one of those things. I can build an Excel simulator for a 6-sided die because we know a 6-sided die rolls at 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. I can do that all day long. I can build a deck of cards in Excel. Why? Because I know exactly how many cards are in a deck, how many are red, how many are black, how many are jacks, how many are kings. You can count cards. I can build a simulator for coin flips. I can even build a simulator for a coin that I know flips 40% heads, 60% tails. But the question here is, what is happening with these coins when we spin them? And we're never going to know exactly. The more we do it, the better our estimate gets, but it's never going to be perfect. And that's what today deals with, is how to deal with that imperfection. Ha! Okay, so the beginning of this is going to be a fill in the blank. I give you the slides. We are going to answer and fill in some blanks together. Now, there's going to be new words for you. So, grab your pencil. Let's go through it. Statisticians want to know measures of populations they're studying. This is a very boring one, but you're a statistician, and you want to know what percentage heads comes up when you spin a coin. It's silly, right? It's a silly thing. But maybe you work for the Power Balance Company, and you want to know what percent improvement on certain athletic skills your athletes get when they wear your bracelet. Just so you know, it's 0. There is no advantage. It's been proven scientifically. But you don't know that at the beginning. You have to test it to see. Maybe you're a pharmaceutical company who's trying to come up with a better pain management solution for folks with certain diseases. And you want to see how efficacious it is. So you have to test it. So you're never going to know for certain because you can't give the drug to everybody with the disease. But the thing you want to know, these measures are called, this word is parameters. Parameters. I'll type it into my PowerPoint with you. If I can. Let's see if I can. I'll try to spell it right too. There we go. Yeah. Parameters. I know that word gets used a couple different ways in a couple different contexts. In statistics, it's a population measure. Now, the next bit down here, unfortunately, the only way to, I gave you some examples there. Somewhere out there is the true parametric percentage of heads we spin pennies. Yes. Or the true percentage of 51-year-old American males with ADHD. Yes, 100%. Or the true percentage of math teachers with top knots. Top knots buns. How about top knots? I had man bun, took out man, and then replaced it with top knot, and I forgot to take buns out, so now it's almost PG. I apologize. Let's get the buns out of there. All right. Now, what we have to do, sit over here. The only way to get the value of a parameter is to do what Ashton just said. Count or measure everyone or everything. You know what that's called?
Survey?
Close. Surveys don't necessarily get everybody. But there is one of these that happens in the United States every 10 years.
Census.
The census. That is the statistical term. A census. That's what goes in right there. Count or measure everyone or everything. I spell parameters wrong? No. Oh, it's saying I didn't know. Census. Yes. That is the only way. That is the only way to be 100% certain that you know the population value. That's it. You got to count or measure every single item, person, thing, whatever. Now, this is problematic. This is problematic, hopefully, because we can never, as Ashton said, spin all the pennies, or measure all the 51-year-olds, or count all the math teachers, and so forth. You can't do that. There's no way you can do that. So, instead, what do statisticians do? Now, I underlined the word random, because we're going to deal with that in the next couple weeks. But they do a random, you know what goes there? What do you do when you select certain items from a larger group? What are you really doing?
Sample.
Say that again, Allie.
A
A
sample.
little bit louder for those in the back.
A sample.
That's a good volume. I appreciate that. That's a random sample. That's a random sample. Sample. Of the entire, use a word we just talked about.
Population.
Not census, population. A census is counting everybody in the population. We're drawing the sample from the entire population. So somewhere out there is that true infinite number of penny spins. We just did a random sample of all that. That's the population. The sample is drawn from the population. And now here's the fun one. We got these today. You got one in number 2 on your warm-up. You got a value, right? That percentage you got on number 2. You also got one at number 4. Number 4 in your warm-up. And we also just got one in Excel. When I looked at all the heads I've gotten over the past 20 years and divided it by all the spins. You say that again. It's a percentage. That's a very specific name for a more general class of something called a statistic. Ha-ha! Statistic. So, here's what you want to know about the difference between a sample and a census. A sample is drawn from a population in total. That means you're never going to be what? 100% certain that what you got is going to be 100% correct. Because there's always going to be that uncertainty. Hopefully that makes sense. So a parameter is a measure of the entire population. When I finished Wordle this morning, and I sent my results to my mother-in-law, and my buddy Terry in Utah, who then sent me their results, they also, was it Terry? Terry sent me his graph of his results of all the games he's played so far, showing that he's better at Wordle than I am. And he's like, I didn't include the margin of error. And I'm like, there is no margin of error. You're better than I am. I can tell by looking at the number of guesses it takes you over your entire career of playing Wordle. It takes you fewer guesses than me. Period. There's no uncertainty there. You've played all the games. Now, might I get better? Might. Probably won't, because I always start with adieu, which they keep telling me is a terrible word to start with. But I'm stuck in my ways now and I can't stop.
You start with what?
Adieu.
Did they let you do that?
Adieu. It's a word, Jasmine.
It's French though.
It's a word, Elena.
I thought you said do it first.
Adieu. Adieu.
How do you spell that?
Adieu. A-D-I-E-U.
So you use the vowels.
All except O.
Yeah.
That's why I start with it. And actually, according to the New York Times statistics of daily players, 28%, no, that's too high. It's not. It's the highest percentage of, it's, most people that play Wordle start with that word. It's like 8% of people that play Wordle start with adieu. More people don't, 92% don't start with something else, like plate or, I don't know what people start with.
I try to use the most common ones.
How do you define common?
Like the ones that I use the most. Like S, T's, E's.
Oh, letters. See, and I know every word has to have at least one vowel, so I get the vowels out of the way right away. So it's a fun, this is where, and we'll analyze this in 243, if you take 243 with me. We analyze starting words in Wordle, because then it's how do you define what's a good starting word versus a bad starting word? We can measure things all day long, but common, best, efficiency, those are things we have to measure somehow. And this is what makes stats interesting. Like we can look, like what's the percentage of heads? It's a slippery number, because we don't know exactly what it is. We're never gonna know exactly what it is. What's the best starting word in Wordle? People argue about that all the time. So we define ways to define what the best starting word. My personal opinion, we'll get off Wordle here in a second. My personal opinion is the best starting word in Wordle is the one that gets you to the correct word the fastest. Simple, right? And that's Terry's claim, is that he can get to his solution quicker than me, in fewer guesses than me. And he can by 0.2 guesses. He's better than me by 0.2. My average is like 3.9 and his is like 3.7 if you actually average his results. So yeah, he does get there a little bit faster than me. But then there's some days like last week where I got it 2 and it's like, you son of a bitch. Like, let me enjoy it, dude. Anyway, off of Wordle. Back to more generalized stuff. Random sample. What's that mean? Tell me your thoughts. You take a sample of something, and it's a random sample. What does that mean to y'all? Give me thoughts. Give me thoughts.
Is it actually random?
Say that again.
Is it actually random? When you do a survey,
What I'm asking is, what does a random sample mean to you, if anything? Now, I love what you're asking. Is it actually random? The answer in almost 100% of cases is no. How many of you have gotten an emailed survey sent to you by COCC? Yeah, see, if COCC were actually sampling randomly, every single one of you would put your hand up in the air, because you've all been emailed by COCC. You've all had surveys emailed to you if you've been here for more than a couple terms. You all got one in the fall about childcare. Every single person in here received a survey in their email about childcare in the fall. But most of you didn't see it, right? That makes it a non-random sample. Or an attempt, a non-random attempt at a sample. Landy, you're shrinkling your eyebrows. I love that. Tell me why you're shrinkling your eyebrows.
because you said everyone got one and I
You did though. Either your spam blocker blocked it, which shouldn't have happened. You didn't see it. It came on October 10th. I know this very well. Let me tell you a backstory about this. I'll tell you a backstory. Last year in October, so October 2023, 2 years ago, October 2023, an email came out from Tyler Hayes, our registrar at COCC. And the subject line was something along the line, we need your opinion, your valuable opinion about childcare on campus. And this is a subject near and dear to my heart because I was on a committee 15 years ago now that did work to check the efficacy or the possibility of having an on-campus childcare at COCC. We did the financial feasibility study, the insurance study, the staffing study, and we discovered that 15 years ago we could have afforded to do it on the Bend campus. And we were super excited. We brought it to the administration, and they shot it down and said we couldn't afford it. And I said, did you read the report though? Because we actually can. And then the administrator that I was talking to said, well, I can think of 10 other things we could support. Like, I'm gonna stop you right there. Since I'm also on negotiations, you could also fund the other 9 things you're talking about. Have you seen the budgets? Because I have. And have you looked at my feasibility? Because I have. And it got shut down right there. And I was so pissed. so upset because we had spent a year of work doing this and it got shut down by one person who didn't actually read the report, which is pretty much how government works. This sounds like government. So fast forward 14 years, 13 years, 2023, October, an email comes out. We need your valuable opinion about childcare on campus. And I get them because I'm a student at COCC as well. I take a cross-training class called Total Fit. And so I was like, oh, maybe they're finally going to take this seriously. So I open the survey up. First question is, are you a parent at COCC? So I said, yes. Second question was weird. It was about like, are you parenting alone? Do you have a partner? It was a bunch of different choices. So I said, no, I got a partner, my wife. And they said, thank you for your information. I'm like, that's hardly any information. So I backtracked who said it. It was Tyler. I sent him a note. I'm like, dude, what is this survey? He's like, oh, the state makes us do that. I'm like, then why did you say it was important? Your subject line said it was important. If the state's just making you do it, why do you make it seem like students should take their time to do the survey? I never heard back from him. So I kept that on the back burner. And then this year, 2024, October, it happened again, exact same survey. So I sent Tyler a note. I'm like, dude, okay, so now I'm pissed. Because now you're sending the exact same survey out, and I predict you're staying it because you have to do it because the state told you to do it. Well, yeah, but we're thinking about, we're going to get really good information. I'm like, you're not getting any information from it. First of all, most students aren't seeing it. Most students aren't seeing it, which means it's no longer a random sample. A random sample, just to get her back to this question, a random sample means that every single item in the population has the same chance of being chosen. Every single item in a population has the same chance of being chosen. And my gripe with the school survey, and my gripe with any emailed survey that is sent out, is that if you don't look at your email, you have no chance of being chosen to participate, do you? If your spam filter blocks it, you have no chance of being surveyed. If you're a busy parent who doesn't check email that week, you have no chance of being heard. So if you had me in class last term, you remember I sent out my own census, did I not? I waved extra credit points in front of you. I said, hey, if you do this, I'll give you 5 extra credit points and I'll put your name in a hat for 10. I gave you a carrot. You're gonna wanna do this. You wanna do this thing. And anybody that did that survey got 5 extra credit points, and I had a 70% response rate. I wanted 100%, I'm still pissed I didn't get everybody. Some people are too busy to take it. But I had a way better response. One of the things Tyler said, well, I got a 10% response rate. I'm like, you got a 10% biased response rate. How many parents have you heard from? Well, it's funny you mentioned that. I'm like, no, it's not funny that I mentioned that. That's a statistical almost certainty. Maybe you should listen to the shit I've been saying for 25 years. Maybe. I don't know. They don't. So a random sample means everybody in the population has the same chance of being chosen. So suppose I had to choose someone at random from this room. What's a good methodology for ensuring that you all have the same chance? Al, you're in. Sorry. Was that random?
No.
It could have been. You have to ask how I chose Al.
You're in front of me.
I was right in front of you. That makes it non-random. What would be a random way to choose? Okay, that's a good one. Allie just said I could close my eyes and spin around and throw things. I have a safer method. You ready for this? I'm gonna give you a number.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 of you in this room, okay? I'm gonna go into Excel, create a new tab. My random student. Okay, you ready for this?
Yeah.
Let me know when you're ready. I'm gonna press enter. Ready?
Yeah.
Who's it gonna be? Who's it gonna be? Number 11! Who's my number 11, Josiah? How do we feel about that random selection? Does that feel random? Does that feel random?
Yeah.
Suppose I needed somebody else. Somebody want to stop?
Stop.
Number 9! Who's that? That's right. Oh, how unrandom. both in the same row. That doesn't feel very random, does it? But can you argue with the randomness there? No. I'm basically rolling in a 16-sided die, right? It just so happens that those two numbers are very close to each other, but that's randomness. We're going to study this more next week. Where's the next person going to come from if I did it again? Where's the next person going to come from? Who's it going to be? What do you think? What do you think? What do you think? I'm feeling saucy. I think it might pick Josiah or Ray again. I'm just throwing that out there. It did not! It picked 16! Oh, this is so broken. It's so broken. It's everybody from the back half of the room. That's random, right?
Yeah.
This is totally different than me going, I need a random person. You're elected. Right next to me. It's called a convenience sample. That's what surveys really are. They're convenience samples. It's an easy way for people to send a bunch of crap out and then get a bunch of stuff back and pretend it's meaningful.
Yeah.
They're almost never meaningful because you've got biased results. Does that make sense?
Yeah.
The only way to ensure a perfectly and I'm not saying it's easy. Random samples are a pain in the ass. They really are. They're never perfect, almost, because it relies on human nature. But there are ways to make it more random. Is that fair? You buying this? Okay, good. We'll talk about that more as we go through today. All right, back to the PowerPoint. So, we now know what a random sample should be. It's a good ideal to have. We very rarely can't get it perfectly. Typically, on average, more about that word on Wednesday, the statistics value that you get will be close to the parameter you're looking for. Okay, I'm looking back at Elena now because Elena's never happy with how many trials I do. Appreciate you, by the way. Appreciate you. So here's the deal. Let's go back to the pennies. Back to the pennies. We want to know what the percentage of heads is if you spin a penny and let it fall. We want to know the percentage of something. That's the one we started today with. We now have a statistic. Ours is 41%. Overall, it's 44%, 43.8%, something like that. This statement right here says, on average, the statistic we got, let's go with our 41%. That 41% is going to be close to the parameter. But what does close mean? Anybody? What does close mean?
Maybe like a percentage off.
Ah! That's a good answer, Ashton. Say it again, it goes in the back.
A percentage off.
A little bit louder.
A percentage off.
That was good! It's going to be off by a percentage. Girlfriend, nailed it. On average, it'll be off no more. And as I was typing these in, I realized, I'm like, if you read ahead, you'll know what goes in those three blanks. These three blanks right here are answered in the next three words below them. It'll be off no more by a... You say it again, Ray!
Margin of error.
Thank you for not having me repeat it a third time. And guess what? In the case of these pennies, Ashton, it's going to be a percentage. So that margin of error, has to be added and subtracted to and from any sample statistics. So that Ashton just said it's going to be off by a percentage, and you have to go up or down from that percentage. It's basically wiggle room, because you didn't flip all the coins or spin all the coins or check all the 51-year-olds. You have to give yourself some wiggle room to alleviate. And what you're forming is known as a confidence interval. Confidence interval. Oh. Oh. Goodness gracious. Interval. There we go. And what you're alleviating, this is a fancy term, sampling error. This is not bad. This is not bad. This is a fact of statistics. Every time you draw a sample, you're not going to hit exactly what you're looking for. You're going to get close to what you're looking for. Did you notice that when we looked at all the 20 plus years of results in my Excel spreadsheet, when we looked here, look at all these percentages. 43, 39, 42, 43, 43, 45, 43, 43, 38, 39, 42. They're all a little bit different, aren't they? That's sampling error. That's sampling error. Due to all kinds of things. Atmospheric changes, differences in how the pennies are interacting with the tables, all kind of stuff I can't control. Some things I can control, like maybe you go 10 times, making sure that you get the penny spinning on its axis fully, things like that. But we can't control for all of them, that's the sampling error. So, oh, Elena, go, please.
13% range.
From the highest to the low?
As high as I can see.
Okay, so yes, I believe, yes, let's go look at this again, my dear friend. Elena's concerned because we've got the lowest 36
Oh, it is.
and the highest 51. That's actually, what is that? That's a 15% range. That's a 15% range, up and down. Shoot. How do we control for that? But do you agree, Elena, I like that, the 15% range. Do you agree that something interesting is happening not at the extremes, but near the middle of the results? Do you agree something, what kind of a, what do you see in here?
A bell curve?
Yeah, we haven't even talked about these yet, but you've heard of them before, where you get extreme values, but then you also get more common values happening towards the middle. Go ahead, Elena, what's in your mind?
Isn't it like 65%?
Oh, we'll get to that. Yes, the answer is yeah. I always remember 2/3, but yes, go with that. Ashton, our 41% is probably wrong. So here's where we're at so far. I'll spin this back so I can see what the hell I'm doing. Okay, so penny spins. We want to know the percent of heads. That's what we want. We want to know what the percent heads is. Parameter, we're never going to know. You're never going to know the parameter. Just admit that now. We're never going to know the true percentage of heads that comes up when you spin a coin. It's out there somewhere, but we only get little snippets.